Welcome to Khetz Tutorials, and in this video I'll be talking about the fundamental counting principle. So this will be a short video, as I just want to do an introduction on this. I will touch up more on this in the next video. So the fundamental counting principle is used to determine the number of different ways to accomplish different tasks, and it states if there are m ways to perform a task and n ways to perform a second task, the total number of different ways in which both tasks can be performed is m multiplied by n. So I have a simple example here which I can use to demonstrate what the principle actually says. So we're told that a security system requires a user to choose a security code, and the code consists of 4 digits. How many different codes can be chosen if the system allows repetition of digits? So here's something that you are expected to know. So when we talk about digits, we're basically talking about the numbers 0 to 9, because the code consists of 4 digits. So there are 4 places that can be filled with any of the values 0 to 9. So the total of that should be 10, because if you count from 0 to 9, then there are actually 10 digits. And another thing that you're expected to know is the number of letters in the alphabet. So there are 26. And so these types of questions require you to know the number of options that you have. If it's not stated, if this range of digits is not restricted, then you basically are expected to know that you have 10 digits in total. And if the alphabet is not restricted, then you're expected to know that you have 26 letters in total. So in this particular example, for the first part, we want to create this code, which can be 4, 5, 6, 1, anything basically, right? Remember, just like with the tree diagrams, you had options, right? Now, when we say that we can repeat the digits, we're basically saying the options are the same throughout. So it's like taking something and replacing it so that the total number remains the same. So it's like replacement. You can view this as replacement if you want. So after using a digit, we don't rule it out, or we don't say we can't use it anymore. And that is what is meant by this repetition of digits. So there are 10 options for the first position, 10 options for the second position, 10 options for the third position, and 10 options for the last position as well. And if you multiply this, we have to multiply according to the principle. We have m ways to do this and n ways to do that, m ways to do this, n ways to do that, if you want to allocate the m and the n in different ways. But basically what the principle says is if you have a certain number of ways to do this and a certain number of ways to do that and a certain number of ways to do that and a certain number of ways until you finish the number of things that you're trying to do, you basically multiply all your options. So now that we're allowed to repeat the digits, each position can be filled by 10 possible digits, right? Or one of the 10 possible digits. And the answer to the first one would just be the multiplication of all of these, and that would be 10 to the 4, right? Which is also the same as 10,000. So that is the first part. But in the second part, we are not allowed to repeat. And just like with the tree diagrams again, let's say you had some options and maybe you had items in the bag, and after taking one item, you do expect to have less items with the next iteration, right? So if you had, for example, a green ball, a blue ball, and a red ball. Now, if you take a green ball, then you can only have a blue and a red ball left. If you take a blue one, you can only have a green, and so on, right? So in this case, if we were to fill those 4 positions, if we were to have 10 options, we are bound to choose one in the first position. So the next position will be filled by one less of the options. So we have one less option to choose from because we would have taken that one over there. And the question says we're not allowed to repeat the digits. So once that digit is taken, whatever it is, we basically take it out of our options. And that is why as you go along, you basically have less digits to deal with. And once again, all that you have to do is just basically multiply your options, or multiply the options that you have for each of the positions that you're supposed to fill in with your digits. And the answer that you get from this is 5040. So that is the fundamental counting principle, just a basic overview. And in the coming videos, I'll talk about other notations and how to deal with special cases of this fundamental counting principle. So I hope this was useful. I hope it was a good introduction. If you liked the video, just give it a thumbs up. If you haven't subscribed, please subscribe, and I will see you in the next video.